computer science is basically a very vast field, obviously, and it's not about as you see in the first graphic, computer science that I shown here, is that it is not a study of the computers, just like physics or astronomy is not the study of telescopes. So you basically, what you're doing is you're using computers as a tool to understand this world and help change different parts of our lives in ways that could benefit humankind. So that's what we're trying to do through computer science. So the machine is just a tool to achieve that. And you do this through the use of this tool, just like an astronomer would use the telescope to look at the stars or the night sky. Okay, so some of the folks are still joining. And Mubin, would you admit them?
Yeah.
Okay, please do that. All right. Oh, I can't. Oh, there's some difficulty. I can't change the slide. So give me a moment here. All right, okay, now I got it. All right, so computer science. Well, like I was saying, basically the science behind computers, not just the science, also how these computers, not only how these computers work, but how can we use them to make it a better tool for the humankind. So you will see that it's basically the study of the principles and the use of the computers rather than the computers themselves. And as I will go through these lectures, these slides, you will notice that there are many aspects of computer science that have basically nothing to do with the machine itself, but how we employ it for our purposes. There are different fields that are very close to computer science, like computer engineering. So it has to deal with the engineering part. So usually in the universities, computer science is part of the natural sciences department. So computer science and the natural science and math, they fall under the same college. While as computer engineering, it falls under engineering college. So there is a difference between what computer science can do. So if you intend to do the engineering aspects of this computer science, then what you would have to essentially do is you would have to look at the computer engineering department to do that, because what you would learn there is the use of these the hardware aspects of how to build things that employ the use of computers in that aspect. Now, there's also a field which is a very popular term. It's called information technology. Actually, there are very few universities. There are some universities that will give you a degree in information technology. But most of the information technology consultants or information technology technicians or information technology experts have either a computer engineering or a computer science degree. Some of them might have even an electronics degree. And some of them might have come from some other degrees using other degrees. Like if you go to India, there's a dearth of the number of students who are in this field. So you will find people who have trained in something else in college, but they have actually gone through a training and become IT specialists. So IT, information technology, you will see there is some places where they will offer, but very few. Most of the big universities will offer a program in computer engineering or computer science. So if you want to go into IT, so you would have to go through these routes, unless you want to go through some of these schools where they have a specific degree for information technology. Very few offer that degree specifically. All right, so I think there is some issue with the slides. Can't move them. Sorry. Okay. All right, so the areas of focus that you see, maybe we will look at, say, University of Maryland. There's one of the focuses area is artificial intelligence, a big field. There might be algorithms. Those are kinds of the paths that you would take. Now, some of these, what you're learning here, software engineering, security, databases, human computer interface, vision, computer vision, graphics, bioinformatics, programming languages, the networks, all of this is basically these sub-focus areas that you would learn as you go through this field, the computer science field. Then you might want to go specialize into, say, artificial intelligence. And I'll talk about artificial intelligence as like a subfield of computer science. And then this artificial intelligence itself is like a vast field. And then you have software engineering, where you learn how to write applications, where you learn the principles of basically writing applications. You learn the methodology of how you create software. So that is software engineering. So if you want to become, say, a web developer, or if you want to become an application developer, so you would probably learn about software engineering. But nothing in computer science is basically, you cannot be a computer scientist if you haven't gone through algorithms. So you need to learn algorithms to be able to do that. To basically write those programs, you need to understand, well, how algorithms work. So that's one of the essential requirements for a computer scientist. So if you go through any program, you would have to take at least one course of algorithms. And security, you can become a security expert. There's so much basically dearth of computer security experts in the world today, particularly with everything going internet-based. So even everyday objects that we use are internet-based. Then you could become a database administrator. So database administrators, there are lots of this data that needs to be stored in different ways. So you become database administrators. Human computer interface, where you have basically devices that connect with the computers to do a certain application. So you basically are looking at, say, for example, a machine to handle some of your actions. And I'll show you some examples where we use those. Vision, computer vision. So human beings, it's very easy for human beings to look at objects, right? And then when you look at these objects, you can, most of the time, recognize these objects. But it's not so easy for computers. So what we do usually is that there is a field called computer vision, where you make a computer understand the 3D world that exists and basically present it to you in a 2D space and understand this world in that 2D space. When I say 2D space, I'm talking about images. So when you capture an image, the computer has to understand that image and go through it and know what's happening in the image. Well, it's very easy for human beings. Say you pick a 3-year-old and ask them, like, what is in this room, or a 4-year-old, they will be easily able to say there's a table, there's a chair, this. But it's not that easy for a computer. So basically, there's an entire field, which is one of my research areas, computer vision, is where you have to make the computer learn how to see the world. Then bioinformatics is a combination of biology and information technology. So information, computer science, and biology came together to become bioinformatics. Programming languages, right? Java, you might have heard of that. Python. There are lots of Ruby. There's JavaScript. There's plenty of languages in the world. There's probably more than the natural languages that we speak. There are so many languages, but you don't have to learn all of them, because some of the principles that we apply to one language is the same. So in a computer science course, if you go to a computer science course, you'll probably learn 1 or 2 languages. You'll learn maybe C++, or you will learn Java, or maybe you'll learn C and Python. That's it. Or JavaScript. And then basically, after you have learned these, then you have the capability to go graduate and then learn other languages on your own if you need to, because most of these languages are specific to a given task, not a small task. I mean, they handle information in different ways. So what you're basically trying to do is you're trying to learn a specific language for a specific purpose. Say, for example, I want to learn, hey, computer vision. So I think if you ask me, like, hey, I want to do computer vision research or machine learning research, what should I do? Well, in that case, what you should do, I would recommend do Python or do R. R is a programming language, basically a scripting language. Do R or do MATLAB if you want to do computer vision. but I would say even C++, but don't do Java. That's not as useful for computer vision or machine learning. If you come back and say, I want to do web programming, I would say, hey, do C sharp, do Java. You might be good. You do JavaScript. Everything in JavaScript is now, it used to be a front-end language. Now it's a back-end language too. So it's kind of a combination of everything. So do JavaScript. Um, and that is kind of dependent on what you're trying to do, right? So once when you think about this field, you have to think about like your end goal, like kind of the job that you're looking for. And when you look at that kind of the job that you're looking for, then you need to decide which courses you would take in the computer science department to which you go to. Okay. All right, I think when somebody joins, I think then this kind of takes a pause and I can't change the slide. All right, I need to, give me 1 second before I can, okay. All right, it's stuck again, sorry. All right. All right, so let's say algorithm, right? So algorithm is one of the courses I teach. So algorithm is basically, um, it is a sequence of logical instructions, right? And this sequence of logical instructions take an input and they transform this input to an output. Say you have to make a biryani, that's the output, right? So recipe in that case would be the algorithm. It's the sequential step-by-step approach of how we will convert this. What do we convert? The input. Input is the ingredient. So algorithm is something that you will learn. You have to learn as a computer scientist. You basically try to figure out how do you create something. So you're given some input. It may be as simple as a set of numbers. And then you are being asked to sort those numbers. So they're unordered. Now you're being asked to order those numbers, 3, 2, 5, 1. So the order would be 1, 2, 3, 5. So you basically are asked to do that. And the algorithm that you write is a sequence of these instructions that the computer understands and converts those numbers from that input, which is unordered, to an ordered output. So here a recipe would be an algorithm. And the ingredients would be the input. Those ingredients by themselves don't do anything. And then you have this output, biryani, right? So the biryani is like the one that you want to taste. So that's the output one that you would like. Okay. All right. By the way, the origin of the word, and you should know this as Muslims too, is this Muslim called Muhammad ibn Musa al-Khwarizmi. So it was basically corruption of his last word, al-Khwarizmi, because that's where he came from. That place is now called Khiva, and it's in Uzbekistan. And so that word algorithm is basically derived from the last name. So it came from Muslims. But here's one thing that I want you to remember. Like, this is great, right? It is from some heritage that we belong to. But that's it, kind of. Most of the modern world changes that are happening is we're kind of lagging behind. So we need to kind of come forward and own it and basically make use of it and transform it the way we benefit. So we basically need to get involved more than we presently are in many different ways. So algebra, actually, he wrote this book. This is very famous, Al-Kitab al-Mukhtasar, right? Fi Hisab al-Jabr wal-Muqabala. So this is a concise book of equations, balancing, and arithmetic, right? So that book also came from al-Khwarizmi. So that algebra word came from there. And then there are different types of engineering, like software engineering. So software engineering is actually this branch, right? So that branch of computer science where you create software, you build software. So that's why Bill Gates was a software engineer, and Microsoft has positions for software engineers. Google has positions for software engineers. Apple, big companies, they have all positions for software engineers. So you go through this computer science course, you learn different programming languages, you learn different these techniques to solve problems. You learn algorithms. Basically, algorithm is kind of the blueprint, right? So the blueprint of how you solve a problem. And then how do you actually solve the problem? You use a programming language to do that, because that's the one that the computer will understand. It's a digital machine. It'll understand zeros and ones. All right. So then there's computer security. Okay, so the computer security is a big kind of in demand discourse, computer security, where you essentially are trying to secure the systems, particularly in this world today, because most of the computers, the architecture, the infrastructure is going to cloud. And that's kind of the future. So initially, what used to happen is every company, say Google or Amazon or some other company, maybe apparel company, they used to have their own IT department, which still exists. It's not gone totally. So they have their own IT department, they have their own IT administrators, they have their database administrator, a programmer, a website designer, and all those people, and then people who support those systems, computers that people work on. Say when I got the first job, I was working in a tractor. Well, I was working at a tractor company for an IT company. So I worked for Wipro Technologies, and Wipro placed me at this place that manufactured tractors. Now that tractor company did not understand how to use computers, right? So, and they did not know how to fix computers. So Wipro had this contract, so they would kind of fix them. So they would send engineers like myself to go there and help them with their computers. So these companies used to have their own infrastructure. Now that's moving to the cloud, which means companies, big companies kind of create this infrastructure. And then you, as a small company, you basically hire those services and you hire those resources on those clouds. That's Amazon or Microsoft. Those are like the top ones. And they basically give you all the infrastructure that you might need, and they take care of it. So you don't have to have your own team. You don't have to worry about how to secure your systems. You don't have to worry about how to update your operating systems, or you don't have to worry about updating applications. So you could basically delegate all those services to this company, maybe Amazon. You pay them, they'll take care of it, and then you do the job that you're supposed to do. You make clothes, you make tractors, whatever you want to do. And but the IT part goes somewhere else. So if you want to go into computer security, there are lots of jobs that are available, because everything is kind of connected these days. Even the light bulbs, right? The switches, light bulbs, your laptop, your iPad, your cell phone, everything is connected. Water, electricity, whatever you think of is becoming like this Internet of Things, where every device is an agent. It has internet connection. They're connected to each other. They need to be secured, because if they're not secured, it's a national security risk. Your water connection can be affected. The AC of a building or of a power plant can be affected. All of these aspects are connected to the internet. So there's a huge demand for computer security. That's one of the fields in computer science that you can learn. Now, another part is the digital currencies, right? Cryptocurrencies. There are people who will basically maybe do crime using cryptocurrencies. These are, you don't know, like the person has bought it, but you might not be able to figure out. It's not controlled by the bank, right? So you basically, the bank, if you transfer money through a bank, the bank will know who transferred to whom and where it went. But when you do the cryptocurrencies, it is a digital currency. So you don't basically, it is difficult to handle those. So there's security involved. How do we know? How do we figure out? How do we find out how do we protect this asset? It might become tomorrow the currency in use, the one that we're going to use in our world. The paper money might go away because people will be all connected through these devices, and internet is the source. So we'll continue doing that. Then Internet of Things, like I was saying, each of these systems, the small objects of the world that we use, are basically connected through this internet. Okay, and I will see if there is a question. Okay. All right, give me 1 second, please. So I think Mubin is not able to hear me, so he wants to rejoin. So I will pause. Okay. All right. So 1 second. Let me, there's somebody in the waiting room. Let me let them in. Okay. All right, they're in. Okay. All right. So let's go back. Sorry for the interruption. So then there's the database administration. By the way, the database administration is actually something that you don't become a database administrator by just doing the undergraduate degree. You have an undergraduate degree in computer science, so people know that you can do stuff in computer science, IT related. Essentially, what most of the people do is they go through some kind of certifications, because there are some big database companies. So there might be a database company like Oracle, right? That's one of the largest, most used databases in the world. So you have to organize your data into databases. So databases provide this methodology to organize huge amount of data and access that data at a higher speed than you would normally. And so there's a company called Oracle that kind of leads the way for the world right now, but that's changing. And I'll talk about that. So what you do is you do some kind of certification. You might do SQL certification. So Microsoft SQL. Microsoft has MS SQL. And then Oracle has Oracle database. So you'll learn through those, and you'll do certifications after you graduate, and that'll make you a database administrator. Huge demand for database administrators. It was even more before this, the cloud computing started. Now you want to learn how to manage databases in a cloud environment. That's the new, that's the future. So basically, even though right now you might think like Oracle as the top, right? If you look at the databases that the world is using, Oracle is number one, MySQL number two, and Microsoft SQL Server number three, and so on. So if you see, like there are Microsoft Azure, okay, and then Amazon DynamoDB database. All of these are like low right now, but the trend is changing. Right now, Oracle is the leader. Microsoft is at the second place, but they have cloud, Microsoft and Amazon. And that's where most of the world is going, like I was saying. So they will change this and move on to the real world, to the cloud world, so that you have to learn to know how cloud works. So most of this data is going to go into the cloud. So those companies, Microsoft and Amazon, are going to take over if Oracle doesn't change how it works. Now, human-computer interface is another subfield of computer science where people basically can use devices to interact. So it might be VR, virtual reality, or it might be gesture control. It might also be maybe for people who have maybe disabilities, like motor disability, and they cannot move their limbs, but they can still think. So if they're thinking about some action on a computer, their robotic arm can understand what's happening in their brain by understanding through their brain signals, which might be EEG, like you see in this slide, in this graphic lower left. And then here you will see a robotic arm is basically helping this lady drink from this bottle. That's because the computers, through these different complex programs, understand what's happening in the brain. So you capture the brain signals and then try to operate the robotic arm. So this is human-computer interface, where you basically interact with the computers, which might be virtual reality or touch interface, immersive media, and those. The biggest that you might have heard a lot about is artificial intelligence. So artificial intelligence is this big area, okay? And in this big area comes natural language processing. So we as humans speak natural language. For computers, it's very difficult to understand this natural language. It is very hard for a computer to kind of make sense. Think about idioms, think about the way we make sentences, and that varies from one language to another. The subject might come first in one language, the subject might not be the first word in another language. The gender and all those different variations in different languages. So it's very hard for a machine to understand. So there's a subfield called natural language processing. There's machine learning. That's what you might have learned. So machine learning is a technique where we try to teach machines so that they can learn to solve a problem for us. So an extension of machine learning is deep learning, where we use some of these questions, so some of these networks in machine learning, to answer more complex questions and solve some of the problems that were not possible before this. And then there is robotics, right? Robotics is also accompanied by computer vision, where we are making the devices see the world, maybe at an autonomous car, it has to stay in its lane, it has to look at the car in front of it, it has to look at the car in the next lane. If it wants to take a turn, it has to make sure there's no person, it has to stop at a traffic sign, at a stop sign, it has to look at the trees and the buildings and not run into them. So all of this needs this computer vision technology that basically, so that this device is able to look at the world, the outside world, and understand it. So if you look at this AI, we basically are using it in all aspects. If you look at machine learning, if you have gone to Netflix, if you have gone to Amazon, if you have bought anything nowadays on websites like Amazon or Walmart, you will notice that these are basically this machine learning algorithm running behind the scene. That's essentially taking all this information and making the machine learn so that they can learn what your preferences are, how you are purchasing, what kind of products, which kind of products go with which products. So all of this is essentially run by these algorithms. So here's the question. So if you are basically in this world where there's all these algorithms that are running, why not be at the front seat? Why not be in the driver's seat? Basically learn this and kind of drive the world in the right direction. Because people have biases, and then those biases get into these algorithms, and you want to be able to kind of hold on to that and try to fix that. So why not be part of it? So there are autonomous cars that are driving on their own. Again, part of artificial intelligence, uses computer vision, uses LiDAR, depth data, uses mechanics, robotics, mechanical engineering. So basically to interact with the outside world. Now, then there is essentially the career opportunities in artificial intelligence. Like there are different ways. So you can become a machine learning engineer. You can become a data scientist. You can become a research scientist, a data analyst, which means you're understanding the data and interpreting it. So data scientist is a more complex term. And then machine learning engineer, you basically write machine learning algorithms. So if you work for Amazon or Google, you basically, they have a lot of requirement for machine learning engineers and data scientists. I'll talk a little bit about data scientists in a few minutes. So Alexa, again, artificial intelligence, machine learning, learns about natural language. We speak to it, it'll basically try to understand what you're trying to say and then respond. Not easy for a machine to do. An autonomous vehicle. And all of these essentially need a lot of learning, a lot of patience, a lot of hard work. So the machine learning, one example is supervised learning. So we tell the algorithm, hey, here's a picture of a cat. I'll show you 100 cats. And then here's a picture of a dog. This is a cat. This is a dog. Try to understand how this dog works, how the dog looks like, how a cat looks like. This is called supervised learning. And then when you show it a new cat image, if it has learned well, then it'll essentially be able to recognize it's a cat or it's a dog. So learn from the experience, learn from training. As a human being, you know, when we teach a child, we tell them, here's a dog, here's a cat, and then we don't show them all the cats and all the dogs. And so what they do is they kind of learn from their experience, what they have seen a dog looks like, and then use that information. This is semi-supervised. And computers are also being in that realm where we have semi-supervised. We tell them some examples, so they learn some of them. And then we do unsupervised, where we don't tell them any examples. We don't tell them this is a dog, this is a cat. We just tell them to see the similarities or the difference. And if you see similarities, put them together. If you see dissimilarities, put them separate groups. Now, data scientist, this data scientist is a slightly complex term. Okay, so there are different definitions. A data scientist is kind of a jack of many trades. So they might have to know some math and statistics. By the way, if you want to go into machine learning, if you want to go into artificial intelligence, you want to be good at math. You want to take statistics. You want to take mathematics courses. You want to be good in linear algebra. So all of those are very important. If you want to be a web developer, maybe you can skip that. You don't need to probably do that. If you want to be a database administrator, maybe not. But if you want to be a security expert, you might want to learn about cryptography, which is mathematics. So you need to learn that. If you want to be into machine learning, yes, mathematics. So data science lies in the intersection of this Venn diagram. You need to know some hacking skills, some machine learning, some math, statistics. You need to know you need to have some expertise of the domain knowledge. So if you're dealing with clothes, or if you're dealing with toys, so you need to have some knowledge of that. So it's kind of you need to have more information. You need to learn more as a data scientist, but you're also being paid more. Now, in this whole field, one of the newest areas that I wanted to talk about is called the generative adversarial networks. So this generative adversarial network is like it creates data. So for example, if I want to create like a cat image, okay, at first I'll give a noise, and then I'll tell this generator, hey, create a cat for me. It cannot create a cat in the first instance. Then there's a discriminator. So the discriminator is like a policeman. The policeman looks at the fake currency note and the real currency note, and it sees the fake and says, oh, this is fake. And so that's what the discriminator does. So discriminator looks at the first image that the generator generates and tells it, hey, this is wrong. This is not a cat. And the generator learns, oh, this is not a cat. I need to do something else. So it tries to make second attempt. And then the discriminator says, well, this is not a cat still. And at some point, the generator wants to basically deceive the discriminator. And at one point, after giving so much feedback that this is not a cat, this is not a cat, so the generator kind of learns what not to do and what to do, and creates an image. That image would look like a cat. And so that's the generative adversarial network that is very popular these days, that are used in many different places. So here's a game that I'm going to play with you guys, and you can answer in the chat. So one of these children is not a real children. They don't exist. Which one do you think is not a real child? Well, the left one is not a real child. Okay, the left one is not a real child. All right, here. Which one is not the real person? The right one is not a real person. The right one does not exist. Okay? So this image has been generated by a GAN, a generative adversarial network. Here are two images. Which one of these children do you think does not exist in the world? They don't exist. That is right. The left child does not exist. All right, out of all these images, there's only one image that is real, that exists. Rest of them don't. Which one? Okay, so the pit bull, the middle row, the top row, middle image is the real one that exists. Rest of them are all generated by a computer. So all of these were created. They're not real. This is generative adversarial networks. So this is kind of the machine learning we're talking about in today's world, where we can basically create this data out of nowhere. Well, you cannot. It's very difficult, right? So there's a question, how can you tell? Well, you cannot tell because I know this because I generated them. So, and I know these were not from the real world, but they were kind of learned from the data. So it is becoming so good that we can actually show some images of dogs, and initially it'll start with that noise. It'll say, oh, I created this. Remember this one? I was talking about this over here. So it'll first create, the first attempt will be just a noise. It'll be nothing. So that's how you start. And then you continue getting that feedback from the discriminator. So you're looking at a policeman and you're giving them the currency bill, and they say this is fake, and then you basically create another currency bill and this is fake. At some point, one point, you learn so much about the real currency that might not be fake that you create one which is correct. So that's what happens here. It's a GAN. Now, where is the money? So as a computer science, you could, basically these are numbers from the U.S. Department of Labor and Statistics. So you basically can earn a lot of money. But here's the deal: you can make all of this money, but you need to work hard. It's not easy to get there. Okay, so once you're in the computer science as an undergraduate student, it's not very easy to go through that, navigate through all this process. You need to be really good. You don't want to be the person who has written software for an airplane and then you're flying in that airplane and the door opens suddenly and that door was operated by the software you wrote. So you need to be really, really good. And that will be great. Then you can make all this money and then it builds up from here. Okay. So how many years do you have to do to be a software engineer? Well, 4 years most of the time. Most of the companies will hire as a computer science who has done an undergraduate degree, which is 4 years, and then you can become a software engineer. So most of the software engineers would just need a bachelor's degree. In many areas where you get paid more if you have a master's degree. Okay. So these are kind of if you become a data scientist, then there's even more money in there. So these are also numbers from the U.S. Department of Labor. So if you look at your own state, you'll see that is around 74,000 starting, right? So sorry, I had to move this because I had this chat window opened. Okay. All right, so this is the money part. Now the schools, okay? There are, this is the list of the CS rankings. Look at number 1. That's Carnegie Mellon University. It's in your state. It's in Pennsylvania. Look at number 26. That's Pennsylvania State University. And then there's University of Pittsburgh is also there at number 51. So in the top 50, you have 3 universities in your state. Mine is at number 10, University of Maryland, College Park. Carnegie Mellon University is, again, in Pittsburgh. There are 2 universities in Pittsburgh that are in this list. And there should be University of Pennsylvania too somewhere. I can't find it, but it has to be somewhere in this list. And so all these schools are very competitive. Again, number 15. Okay, so yeah, I was looking for that. Okay, yes, thank you. Number 15 is University of Pennsylvania. So you got these universities, 4 universities in Pennsylvania that are basically in the number top 50. And University of Maryland is not that far. It's number 10. Virginia Tech is also in this list, University of Virginia. So you basically have a lot of opportunities, but what you need is hard work, and that is very important. And now the questions.
So, Brother Naeem, I mean, before going to the questions, you were also talking about the summer programs too for middle class and the high school students. Can you also talk briefly about that?
Oh yeah, okay. So there are different universities have actually summer programs for undergraduate students and also high school students. So there's one program being offered by University of Maryland too. I think I had sent a link to those programs, and it might be actually very late in the process. I had sent a link to, I think, Brother Shabazz. So those that has a deadline that is tomorrow, I think. If I'm not wrong, but it is close to this date. That's what I had thought, because I thought I would announce it here, but then I also realized that it's too close to the actual deadline.
So is that all online, or the kids have to go?
Yeah, that's all going to be virtual.
Okay.
Correct.
Okay.
So Mubin is asking, is it possible to get a job in Azure or AWS without degrees, only certificates? Well, most of these jobs are basically, you can have an associate degree and you can get some of these jobs. But the problem is, how far in the ladder can you climb after that? So in many places, you would basically need to have an undergraduate degree to do well, because you will learn some of the principles that will make you a good analyst or a good specialist. How can artificial intelligence be used in the medical field? Oh, great. I mean, you can use it all the way. So for example, the vaccine for COVID-19, basically artificial intelligence played a role because you had to sequence the data, and that sequencing would take usually a long time. And artificial intelligence were able to learn the messenger RNA that was basically to be used to build that sequence and to create the vaccine. So artificial intelligence is basically everywhere, right? So second part, artificial intelligence, I was showing you that example of EEG and that lady being basically able to drink water because a robotic arm was handling it. So how did that happen? The artificial intelligence essentially was a part of this machine learning where we learned the signals coming up the brain and transform those signals into the real world. So I had done a project where we were basically collecting EEG signals, so using probes. So those are not, it's not invasive. So you put these electrodes on the head, 6 of them, and we made the subjects think about the tasks. Say, let's say we asked them to write a letter in their head. So we collected EEG signals, what happens in the brain, that brain activity that takes place. And then you learn that brain activity, and then you make a prediction about whether it's letter writing or multiplication or a mathematical task that they're doing. So there's a lot of opportunities in the medical field. So the bioinformatics, okay. So the bioinformatics is basically a combination of computer science and biology. So at some point, what happened that biology had to do something like, for example, they needed to do this work on, say, for example, gene sequencing. It was essentially a substring matching problem. So there are many algorithms that computer scientists have built in matching these sequences. So for example, you're looking for a cancer gene, right? So you know the sequence of the cancer gene, and then you have the sequence of some person, and you want to see if it has that trigger, and you want to do a matching. So it kind of started through these kinds of problems. And then computer science had these algorithms that helped it. Now, how do you do that? So what you do is you basically start with courses in computer science as a computer scientist, and then you take courses in life sciences or biology, and then you take those courses as out of the department courses, and then you build on that. Now, if you want to go more, then you would basically do masters in bioinformatics. Nowadays, we have undergraduate degrees in machine learning and data science. We don't have undergraduate degree yet in bioinformatics at every place, but there are places which do bioinformatics undergraduate degrees. Okay. All right. So do you personally see any potential dangers in AI? Well, yes and no. So the potential danger is that of human bias. So one potential danger is that humans have their inherent biases. So when you train a model, those inherent biases, when you create an algorithm, those inherent biases creep into the algorithm. Say, for example, here's the issue. So let's say you are including um, race as part of the algorithm. So then what will happen is, let's say we have whether a person should get parole or not. And one of the aspects you would see is that what is the history of the person in the judicial department. So a person, say a person of black race, if there are more people that have been historically incarcerated, then your algorithm is going to give them fewer chances of parole than somebody who is not of that race. So that bias is already crept in. The other problem with AI could be that you basically are essentially don't have enough parameters or enough knowledge about built into the algorithm, so that you haven't thought about what else could happen. Say, for example, in Facebook. In Facebook, the way the algorithm works is you're basically given information which you see more. So the learning part is you see something more and the algorithm looks at it, and this is the pattern that you're looking at. These are the kind of news stories that you're reading. And what it'll show is the similarity stories. So it's like collaborative filtering. So for example, if you watch movies on Netflix, or you want to look at something in Amazon, then it'll look at your pattern of purchases or your pattern of watching movies. What do you like? Then it sees some other person who has similar likings, and then it'll give you recommendations. So same thing with Facebook. So if you see it sees some of these messages that you're learning, so it'll give you similar patterns. So you get stuck in this bubble. That'll happen. Okay. Uh, how are the opportunities on data science? So data science is great because there are actually, like I was showing this slide over here. So most of these, basically, not just the pay, there's the world, it needs data science engineers. There's dearth of data science engineers. So at least for the next decade and more, you basically, United States and the world needs more and more data scientists. Um, do you think AI will impact the world more in the coming years? This is the century of artificial intelligence. All the automation that's happening involves artificial intelligence. But here's what one thing one should learn. Every time there's a change in the industry, or there's an innovative industry that's taking over, basically more jobs are created. It's only, the issue is that the jobs are created in a field which may not be traditional. So the jobs are kind of shifted. So what it entails is that there should be enough training for people to become part of that revolution. Otherwise, there are more jobs when there are more new fields. Because think about it, when there's automation, you need people to know the software. You need people to use the software. You need people to understand how that software, to interpret that software, how to use it. And then you need people to develop that software. You need people to test that. And so all of these factors creates new jobs that we haven't thought about previously. In 2007, before 2007, there was no smartphone. So we didn't have jobs like an app developer. Now, after 2007, it's like less than 2 decades ago. So after 2007, the iPhones came, and then new jobs. We hadn't even thought about an app developer. Somebody will create an app in 2006 or 5, and then suddenly all these jobs, right? So there's a shift of the industry. So we need to train in that field. So there's a dearth of people who know AI. There's a dearth of data scientists, machine learning engineers, security analysts. So those are the fields where there will be trust and there will be lots of jobs. So could AI determine an economic crash? Well, there are many factors involved in economic crash, which are beyond just computer science. And that's where you have to basically get involved with the domain specialists. So people who have knowledge about the field. So you need to involve economists. You need to involve, then you can kind of write a program that might make it easier to understand. But you need a lot more training and information, like how we have been able to gather information about climate change or about weather prediction. Now we can make very good predictions up to like more than a week, up to 14 days, but very, very effective, accurate levels for 3 days or 4 days. That's basically uh, in the uh, predictions for the weather. Okay, so could you provide information on upcoming summer programs that are still available to sign up for? I have to look up for that link. I'll send that link to uh, to the group. Maybe Shabazz Bhai, I sent you that link. Let me check if I have that link. Give me a few minutes, and uh, then I'll post it to you.
Yeah. Nambe, I have the link. I can post it.
Okay, can you? Thank you. All right.
Yeah.
Okay. All right. Thank you. So I think you want to end this. You want to wrap it up
Yeah,
by
it's already
7 p.m.
6:50.
Yes,
Yeah,
I
it's
know.
6:55. So yeah, I
All
mean, if
right.
you have any additional questions,
All right.
so maybe
Sure.
we can take
So
a couple more until 7. So,
okay. So we'll wait until 7 if you have more questions. So please feel free. And
again, Jazakallah for your time, brother
welcome.
Naeem.
I hope
Yeah. I think, I mean, it's
it
been
was
very
beneficial.
informative, very beneficial to everyone. So
All right. Jazakallah khair. I'm glad.
yeah, and also, I mean, Jazakallah khair to everyone. So I know for joining in this event. So special thanks to brother Shahbaz and for helping out with this event, and also, I mean, thanks to brother Mubin too.
And thank you, Jazakallah khair, for having me here. It's an honor. It's good to see you guys. It's a great community in Central Pennsylvania.
Yeah, I think
Any companies offering internship,
you
please
should
let
come
us know.
back.
Well, there are many companies that offer internship. Like every summer, there are companies like big companies and small companies. They always need people who want to basically do internships. So what needs to be done is you need to start early. You need to start like in December, January, to basically start looking for these opportunities, because by the time it's February or March, they have started giving out the offer letters. And then it's only the smaller companies or the companies in the neighborhood that might have some openings. But the big companies, if you want to apply there, you should start early. Start in December, January. It helps if you have recommendations. Say, for example, somebody can recommend you based on what you have done. So usually the way you get these internships and all is that you're doing something beyond what you're doing in class. So for example, you're working on something, you're learning something. Say you heard about autonomous vehicles and you did something. It doesn't have to be innovative or new, totally fresh, totally something that's not been done before. It can be a re-implementation or redoing something that exists already there. And then you put it on your page. So create a GitHub page or create a website, a simple website that you can create those very easily nowadays, and then use that in your resume. So you basically, when you send the resume, they will see that, oh, this person is getting interested, he's learning. So here's what he has done. He has implemented something that exists, which is fine, which is great. You don't have to do something that's totally new and that needs to be like a PhD or an invention, something like that.
Yeah, and maybe I just added the link on the chat.
Okay, yeah. So in the chat, if anybody is interested, the Shahbaz Bhai has added that link in the chat. So you might want to take a look at that. All right, Jazakallah khair. I am so happy to
So,
be here.
Brother
Thanks.
Naeem, in case if anyone else have any additional questions, even after the event, so how can we reach out to you?
You have my email ID and my, so you could probably send those through my email, to the email.
Can you
or
share? Is it
to the WhatsApp.
okay to share your email address with
Sure.
everyone?
So I'll send you my personal email ID. I write it in the chat. If you have any questions, I'll be happy to answer whatever I know. So it'll be I'll be happy to answer your questions to the best of my abilities.
Okay.
All right.
All right. Yeah. And Jazakumullah khair to everyone. So.
All right. Thank you.
Thank
Take
you,
care.
brother.
See you. Assalamu alaikum.
Jazakallah khairan. Thank you.
Yeah.